Okay, I am recording now and we can get started. So we have today with us, after a very, lots of people felt that the meeting was very useful and we wanted to find more out about people who could be partners with us on the CCSTAR program. So we invited Lauren as part of the Open Science Grid, which is a national distributed computing partnership for data intensive research and potential partners for your CCSTAR Campus Compute Area 4 proposal, to come on here today and talk to us a little bit about the Open Science Grid, what services you can offer your researchers, and also a little bit about how they are have provided in the past partnership for the CCSTAR proposers and how they can help you going forward. All right, I'll turn it over to Lauren then. And I think
Thank
I'm
you.
sure, Lauren, you don't care if people ask questions and
Please interrupt me and ask questions.
yeah, it's so hard to just be talking and not have any kind of interaction. So I'll watch the chat box and
Yeah.
people can raise their hands or just go ahead and say, hey, Lauren.
And I know I've talked with quite a few people in the audience, but for those of you who are new, my name is Lauren Michael, and I lead research facilitation for the Open Science Grid, meaning facilitation for both researchers and campuses that engage with OSG. And I'm also the co-PI on the new NSF-funded Partnership to Advance Throughput Computing, which is a significant investment from the Office of Advanced Cyberinfrastructure that funds core OSG services and technologies, as well as expertise and software in the Center for High Throughput Computing at UW-Madison, where I am, which produces the Condor scheduling software, if you're familiar with that. So that's a new 5-year project. And we've got quite a bit to do over those 5 years plus, especially in partnering with campuses. I believe you should be able to see my first slide at this point.
Yep, we can see it.
And I'll be talking about all of the ways that partnering with campuses is really critical to the Open Science Grid's ability to advance the nation's science and engineering work. And knowing that there may be some people here who are newer to the Open Science Grid, I'm going to start with just an introduction to what the Open Science Grid is and what we do. Most of the content in this presentation will be about services for your researchers and for your research supporting organizations on your campuses, including support for NSF CCSTAR proposals and awards. And I'll also leave off with how you can learn more and begin leveraging the Open Science Grid as a campus that supports researchers, and how your researchers can begin leveraging the Open Science Grid. All right, so first, what is the Open Science Grid? And there are multiple ways to answer this question, but I think the most encompassing one is that it's a consortium of researchers and institutions who support them, who have elected to share computing and data resources for distributed high throughput computing in support of open science. This is where the open science part of the Open Science Grid name comes from. Basically, the idea is that entities, including researchers who might have their own computing resources, or entities that support them and have computing resources, can join those together via technologies that the Open Science Grid provides, to be greater than the sum of its parts. And by offering up computing resources, sometimes that are even backfill at a campus cluster or a national lab, or whatever it may be, if those are in backfill capacity, and just because of their sheer number and the ability of the system to sort of deal with resources coming and going, this can really enable work that we refer to as high throughput computing, whereby versus the principles of high performance computing, research problems that can be executed as lots of relatively smaller tasks can really spread out and scale especially well on a high throughput computing system. And you can support high throughput computing on local computing systems. The Open Science Grid is a very large distributed system for supporting high throughput computing. And that's where the distributed high throughput computing term comes from. So you can see that we have sites on nearly every continent. And in fact, there are resources in Antarctica for the Ice Cube Neutrino Project and some others, South Pole Telescope, that in one way or another are integrated in Open Science Grid. But the map here is actually showing sources of computing capacity. Some of those are supporting researchers who are executing work from the South Pole. So really, we're on all 7 continents. So who participates? And we see several different types of stakeholders. They're not mutually exclusive with one another, but obviously we're here to advance research through large-scale, high-throughput computing. And that includes researchers in single research groups, a graduate student, postdoc, people that you may be working with on a day-to-day basis in labs that are headed by faculty. It also includes multi-institutional collaboration. So there are some really large physics collaborations, international even, that really drive the multi-continental scope of OSG, who contributed to research or executed research for, say, the Higgs boson. I already mentioned the Ice Cube Neutrino Project. But obviously, these are large collaborations of multiple research groups across multiple campuses. The Open Science Grid also serves as a useful compute backend for science gateways, especially those whose work is more suitable to high throughput computing approaches. And then, of course, all of these tend to be supported by and include resource contributions or operational support at academic institutions and national laboratories, which makes campuses at these types of institutions really critical to OSG's ability to advance research. And so that's part of why I'm here to talk to you, but it's also part of why we have been looped in to the campus cyberinfrastructure program, not just as an opportunity to extend the NSF's investments in compute hardware through that program into a national shared ecosystem, but also because there are additional services we can provide to campuses, especially like yours, that may be building research computing capabilities and where we serve as an important resource for your researchers to use directly, even through some of our own access points. So the way that the Open Science Grid is organized, it's not really like one large computing system that's a free-for-all. Ultimately, there are different pools, and you can think of these as virtual clusters that are each made up of resources from contributing sites or campuses. And we refer to these as pools, and they're each attributed or supporting certain research communities. So a good portion of the multi-institutional collaborations that we support, especially the larger ones, run their own pool using OSG technologies and software, as well as the DHT Condor software, which is what end users interact with for submitting jobs. But there is also an open science pool that is owned and operated by the Open Science Grid core team for researchers at campuses like your own, who are not part of any of these large collaborations with their own pool. And so we offer access points for these researchers. There are some smaller multi-institutional collaborations that run in this pool because they haven't elected to have control for running their own pool. And I'll also talk later about how campuses can have submit points into this pool. And I see Mike Benedetto's here, not that I mean to pick on him, but the American Museum of Natural History is just one campus that is elected to have their own access point so that they can support researchers locally to have access to resources in the open science pool.
I was terrified about what you were going to say about me, Lauren. It's always a crapshoot when my name is brought up. So thank you. Yes.
Only good things, Mike.
And and just in general, I mean, just if anybody does have questions about how we did it and something that they're considering, myself and suggesting, would be more than happy to kind of talk to you about it. So let us know.
Thanks, Mike. So like I said, OSG operates its own pool for open science. This is the one that CCSTAR awards typically elect to share resources through because it meets the CCSTAR program's intention that the investment made at your campus is contributing in some way to the sort of broader national ecosystem. Whereas the other pools in the grid are for specific research projects or collaborations, or sometimes for specific campuses. So we produce technologies, we then run them as services. And while I don't want to make things too complicated, I'll walk you through this diagram to show you basically everything that OSG Services can do. And then in later content, I'll sort of break these down more simply into separate services that you can engage with. So for each pool, there's an OSG meta-scheduling service. This is software that we produce. And each pool can have multiple access points, which are sort of functionally independent from the compute clusters or resources that end up being contributed to that pool. So researchers can use that access point, and through the HT Condor scheduler running on that access point, this can be a server, that could operate at your campus or that OSG is operating. Their jobs go into a queue on that access point and then have access to different resources. Most typically, and the vast majority of what's in the open science pool, are resources on clusters on campuses and national labs that are just shared, even sometimes with pure backfill capacity, made available for open science. So for all of these research groups that we support. But there are ways, for example, for the user's jobs to be targeted or prioritized on a specific collaborator's cluster. This pool for a particular user can be expanded onto a national supercomputer using an exceed allocation, for example. So if you had a researcher who had an exceed allocation and they want to use campus resources at your campus and want to benefit from the open science grid, they could really run on one queue and get access to all of these things. And that also includes the commercial cloud, because some of the software that we use in Condor or have added on with Open Science Grid can provision cloud resources that run just for a particular user. But the simplest picture is that the vast majority of the open science pool, the vast majority of the time, is a general pool of resources from clusters that are sharing. So, and by the way, that access point can also be made to submit directly to your local cluster. So OSG creates these or develops the software, or otherwise partners with software like Condor, and then leverages a lot of other tooling, including the ability to distribute data across these systems. And we wrap all of that into a service. And with the open science pool, we run that service entirely for researchers and campuses to take advantage of. So breaking this down a little more simply into discrete services, what we have for campuses is one that you can send your researchers to use OSG today. What we call OSG Connect is the set of access points with a dedicated team of research computing facilitators whom I lead that meet with every researcher, help them log into and use our computing systems. And I'll talk about OSG Connect in a bit more detail. We also offer training on using DHTC and facilitating DHTC in case your campus would like to become more involved with actively identifying researchers who can benefit from OSG, or perhaps then pursuing a local access point into OSG on your campus, like the American Museum of Natural History has done. We offer support for NSF CCSTAR proposals in various ways, beyond the fact that we, of course, then support awards through resource sharing. And you don't have to have a CCSTAR award to take advantage of any of these resources. If you'd like to share local resources via OSG for any other reason, maybe it's even preparing for your CCSTAR award to demonstrate that you already know how to share resources, you can get in touch and we can help you with that. A lot of campuses find that useful if they've got excess computing capacity or are setting up a new cluster and know that some of their investment will go unused some of the time. And then by integrating now more formally with the Condor software through the Partnership to Advance Throughput Computing, we also can provide end-to-end services for building local DHTC capacity that can include a local DHTC cluster on your campus. Maybe it integrates cloud resources. Maybe it includes a local access point to the open science grid. All of these are free and open, and I lead facilitation for campuses that are looking to engage with these services. And then in support of all of these sort of technology-based services, we provide multiple learning opportunities targeted for campus IT and research computing staff, including gateway developers and researchers who maybe wear multiple hats. For example, we have a series of DHTC campus workshops. The next one is in February, and I'll talk about that in a little more detail. These often provide introductions to OSG services for campuses, using and facilitating DHTC and OSG, including hands-on trainings. And our February workshop includes a half day of office hours where you can just show up and pick the brains of our team members about various OSG services, including very detailed, say, technical questions about how to set up resource sharing. We do external presentations and trainings at a number of events. I've listed some of those. And then we also execute an annual OSG all hands meeting. Given that OSG is a consortium of entities that contribute and participate of their own free will and with their own objectives served, the all hands meeting is sort of a way for this entire community, and even those who aren't yet participating in some way, to come together and discuss what's happening in high throughput computing and the open science grid. And then we also offer the OSG User School, which is a week-long, usually summer, educational experience, usually at UW-Madison, but last year it was virtual, as you can imagine. And it's targeted both for researchers and research computing staff. And I know some of your campuses have sent staff to that particular opportunity. We always have a spring application period. Usually it's announced at the all hands meeting. So watch out for that too. And as I mentioned, all of these services are now kind of integrated together under one funding structure in the Partnership to Advance Throughput Computing. So if you're interested in that, you can visit the PATH website. I realized I may have put my NSF image over the link to that website, but I'll fix that and we can make my slides available. All right, so let's go through some of these services. And I won't go in too much detail or spend too much time, but I want to give you a sense for what high throughput computing is, how we support your users through OSG Connect so that you can feel confident in sending researchers to us. And then also give you confidence to reach out to us when you want to talk about any of the other support we provide, including for CCSTAR proposals, and especially since the next CCSTAR deadline is a little over a month away. So for individual researchers, I mentioned before the OSG Connect service, which basically provides free access to facilitation and the capacity of the open science pool via an OSG supported access point. Your researchers can go to osgconnect.net and sign up. You yourself can go and sign up. And this is available to researchers at any US academic, government, or nonprofit organization. So even though OSG is international, this particular service being funded by the NSF is just for researchers in the US. It includes an obligate initial consultation with an OSG research computing facilitator. As with any computing service, especially a national one, we have online documentation and examples, central support for software, and ample space for scratch data that can also be distributed across the OSG if it's fairly large data per compute job. In the last year, OSG Connect supported over 250 million compute hours, some of that going to, and actually a significant portion of that going to COVID-19 research. You can see the top 10 projects over at the right, but that third project at Hawaii is a single grad student at University of Hawaii, Manoa, who does large numbers of relatively small and short simulations for astrophysics. So it really runs the gamut in terms of some of these projects representing multiple or sort of larger research groups and efforts like the Folding at Home research project, and some of these really just being a single researcher or research group. And we've got a nice trend of gradual increase in both the number of projects and the amount of usage, which really boils down to the amount of resource providers who are supporting the open science pool. Across the open science pool, including other access points, like campus access points and those for some of the smaller multi-institutional collaborations that are not OSG operated. You can see we've got a nice breakdown of fields of science impacted. And even though Folding at Home contributed significantly to the biological sciences total, even if we remove that, that's still our second category. And then additionally, the institutions that these projects are associated with really vary. I already mentioned University of Hawaii at Manoa. You'll see New Mexico State University there, Wayne State University. Those are both CCSTAR campuses. and a variety of other campuses of various sizes and states of local research computing support.
Hey, Lauren,
Yes.
I just wanted to point out on that slide how I think, like, I used this layout here, this slide, to reach out to my biological sciences researchers. Like, if you're kind of, kind of when we're emerging in these centers, we're looking for people who may need the tools. So this is a really good slide to say, well, I have some biological science people, I have some math people. So maybe I would specifically target to send this OSG to them to offer them the tools. So this is, I think this is really a great chart for all of us to use to be able to identify and share and target our users to say, try this.
Wonderful. And if you're ever looking for additional information that you don't think you've seen from me, please feel free to get in touch. We'll be happy to help you with material that you can show to your researchers and other stakeholders.
Yeah, that's great. Because
these are all on your public grok, right? Like you could generate these numbers.
This is all data that I screen grabbed from our grid accounting system.
Yeah, so because I've just personally, I've used that for not only showing our contributions into the grid, but also what we've used from it. So, you may just want to point out that, the data is there for us to kind of go through. And then if there wasn't something we're seeing, we could always reach out to you guys, or if we want a clarification. But I mean, personally, I've mined that site on a lot of things for our emerging use of OSG. So I think it's a great resource and tool. So if people aren't familiar with it, they should definitely get into it.
Great. Thank you for that, Mike. Right, so here's what the OSG Connect homepage looks like. It's very simple. There's a small Twitter feed below what you see here, but your researchers can go there and click sign up right now. And we'll follow up to meet with them so that they can get started on the right foot. And here's part of what we do there. Often researchers who come to us haven't really heard the term high throughput computing before, and not that they need to understand the ins and outs of high throughput computing systems, but a lot of research projects are not just amenable to, but are significantly enhanced and advanced by high throughput computing execution approaches, which is really similar to the analogy we use a lot in the world's largest cake. The world's largest cake wasn't baked by making a really huge oven or supercomputer as the analogy, but by leveraging regular ovens to make smaller pieces of cake that assembled into a much larger outcome or a larger research project in the end. And we see examples of this really across all of research domains. And in fact, not just in, say, the physical sciences, which is where some of the Open Science Grid's history is. But for example, most genomics is a form of text analysis, and text analysis we see really commonly across the social sciences as well. That almost always can be broken down such that text can be analyzed by page, by chapter, by publication, or by even separate reads in a genomic data set. We also, whenever we hear the term parameter sweeps, that often means that there are a lot of ultimately independent computations, simulations perhaps being run with different starting conditions. The same can be said for multi-start physics simulations, for example, weather simulations that aren't sort of these singular, really large simulations that require HPC, but where somebody needs to run sort of like a parameter sweep, many different starting conditions. We see really similar language and conceptualization around a number of statistical models, Markov chain Monte Carlo optimizations, if any of these terms are familiar to you. And of course, there are sort of the obvious whenever somebody has multiple images or samples to run. Obviously, that represents an opportunity whereby if that analysis, at least in part of it, is looking at individual images or samples, can be run as multiple independent tasks. So that's whether it's high throughput computable. And even some high throughput computing work may require, per job amounts of data or, restrictively licensed software that needs local resources. But we have nice guidance for when computing work is OSGable. On a local computing resource even, or on the open science grid. With high throughput computing approaches, if you've got lots of relatively smaller computations, say they each run on a single core for hours or days, if you've got lots of those and you've got lots of computing resources, you can sort of maximize the availability of that computing resource and reach a peak of total number of cores across all of your jobs much faster. There's no special programming required. Often we see researchers who've developed something on their laptop and they've got a Python program or something in R that's looping over a parameter space. And if they break out of that loop and run lots of independent computations, they can achieve parallelism that far exceeds the number of cores on a single server or even a local cluster. There's easier recovery from failure because if one task fails, all the others can continue running. And things like CPU speed and homogeneity across resources are less important, which is part of what makes high throughput computing so powerful and so distributable across multiple heterogeneous sets of campus clusters. So signs of HTC-able work, any mention of numerous samples, almost anything written by the researcher. Unless a researcher is using MPI programming for a large physics simulation, and this is relatively rare, something that's written by the researcher is almost always going to involve some loops that could be broken out of. Some community softwares that use multi-threading or multi-processing, MATLAB's PAR4 package, if it's written by the researcher, are simply looping over data portions or independent tasks. And especially when we see long-running jobs, often those fit one of the prior categories in that a task is long because there are multiple iterations going on. And even if somebody has multiple long-running jobs, the fact that that task is iterative may mean that it's amenable to self-checkpointing. And so if they've got numerous of those to run, a resource like the Open Science Grid is really amenable to checkpointing too. So we have this table of, is it OSG-able? And I don't expect you to go through and memorize this. It's in our OSG Connect documentation, and you can certainly come back to this presentation if you'd like to. But ideal jobs in the Open Science Grid, at least, just because resources come and go at a much higher rate than on a local cluster, are jobs that use one or very few cores, finish in less than a day, and use a laptop-sized amount of memory. Input and output per job can be up to the sizes that I mentioned here without needing some of the OSG's built-in caching mechanisms. But even with that, we can support jobs that individually need up to 10 gigabytes or so of input or output data, because that's getting moved to and from the servers where the user's jobs are running, which may be at your campus, for example. And then obviously software that is not restrictively licensed is a good fit for Open Science Grid. And we've got multiple insights and tools for helping researchers make simple changes to their software installation so that their software is portable if it's not already available in something like a precompiled binary. And that includes support for containers too. So we use principles of research computing facilitation, and I won't go into too much detail here, but unfortunately you'll get to hear from me in terms of how we've implemented research computing facilitation and sort of define the role of research computing facilitators at UW-Madison when I participate in a panel on this TRACS call next month. So look forward to that, but it really sort of depends on this proactive engagement. And just to demonstrate how applicable high throughput computing is and how likely it is that a significant number of your researchers can benefit from the scale of high throughput computing approaches under the Open Science Grid, I'll draw on some sort of earlier data in the timeline of UW-Madison's investment in a core research computing facility. So the entity I work for, the Center for High Throughput Computing, was invested in 2013 to become UW-Madison's core research computing facility. And even though we're a fairly large campus, partially because of our distributed nature, we didn't have a sort of central research computing entity until then, at which time I was hired, and then shortly after that, a second research computing facilitator on my team. And this is just a graph of the usage of our core facility the year that that investment began, because we'd already been running a computing system, which was part of why we became the site for investment. And then after significantly adding computing capacity, and some of this is represented as OSG usage too, this is the breakdown of different research domains. But when we looked at whether the usage was on our larger high throughput computing system versus our high performance computing system, which wasn't even nearly saturated, looking at the social sciences and life sciences, nearly all of that usage was on our high throughput computing system because it was work that was really suitable to high throughput computing, and it was advanced by systems that are configured for and that favor high throughput workloads. And even looking at our physical sciences in blue and engineering in this teal color, greater than half of what we saw there was on our high throughput computing resource, when our researchers can sort of choose which they prefer. And our HPC system is really just then for multi-node MPI type simulations. So there's definitely high throughput computing going on, or potential for high throughput computing going on in the research on your campuses. And that's why it's really important for us to know, first and foremost, that you can support your researchers today, even if you don't have high throughput computing optimized systems on your campus, by sending them to the Open Science Grid. So I'll transition now a bit into talking about how we support campuses to build HTC facilitation if they'd like. So if you want to go beyond sending your researchers to OSG Connect and become more involved in supporting high throughput computing yourself, that can include building local HTC capacity. But one of the first steps along that pathway would be to learn from, or to learn how to facilitate HTC. And we offer through various events that we run, and also through the OSG Connect service, the opportunity for your campus staff, if you'd like, to learn from our research computing facilitators. So for example, in requesting an OSG Connect account for themselves, your staff will get exposed to what we do, because we'll put your staff through the same process that all of our users go through with initial facilitation and personalized guidance. But then your staff can also shadow us as we meet with researchers from your institution that you send to OSG Connect. Additionally, and in non-pandemic times, this is physical on-site shadowing. Your staff can come to UW-Madison and shadow our research computing facilitators, both in facilitating our local users across various types of computing systems and services, and in facilitation of other OSG users, because our facilitators support local researchers at UW-Madison's Core Research Computing Center, and then we also contribute to the multi-institutional team of facilitators for OSG. And we've talked for some time about building an HTC facilitation community that really is playing out now in the series of campus workshops that we're operating that include facilitation training. So the one that's upcoming is a DHTC campus workshop, February 8th through 9th, so just a couple weeks away. Register now, because the seats for the day one training are just about empty. But that training is on using and facilitating the use of DHTC and OSG. So it'll include presentations, group discussions, and actually hands-on job execution, as well as discussion and sort of training in what we do to facilitate high throughput computing with our researchers. And then day two is office hours on all things DHTC. So there will be breakout rooms on topics relevant to different OSG services for campuses, actually one room for each of the bolded items that I listed in the DHT services for campus slide. And that will start with a brief overview of services for campuses. So again, there'll be a breakout room for each of these services that I'm going through. And the last one I'd like to talk about for supporting your researchers is local access points into OSG. I won't go into too much detail on this. If you want to know more, I would say come to our office hours on February 9th. But having an access point into the Open Science Grid is kind of like having a cluster where you don't have to administer the worker nodes, but you provide all of the user support and the access point for your researchers like you would a head node on your cluster. So that includes user facilitation, if you want to be doing this instead of sending people to OSG Connect, administering user authorization, which means that your users now get to log into their OSG access point using their campus credentials. You'll do some Condor administration on the submit node with support from the OSG team for making sure that Condor is configured appropriately. And then you can administer and integrate any institutional data storage, including integration with OSG's technologies for caching data. So we do all the caching work, but you can operate a data origin based upon a file system that you already have in existence. And importantly, you can have an access point into the open science pool without needing to share resources. Those services are completely decoupled, and there's no expectation that you share resources in order for your researchers to be able to benefit from having a local access point. And just like I mentioned before, with all of the different types of resources that can be integrated, that applies also to local access points that you operate yourself. So in addition to access to the major contributors to the OS pool, so campuses, researchers on your campus can have one submission point that allows them truly to submit locally and run globally across additional commercial cloud resources or allocations that they might pursue with national clusters. So let's move on to something that I know is very timely and important to certain members of this audience, and that is our support for CCSTAR proposals, which ties in really intimately with our services for sharing local resources via OSG. And if you've looked at the most recent Campus Cyberinfrastructure, or CCSTAR, program solicitation from the National Science Foundation, you've probably noticed that, as in the past couple years, there is specific mention of a requirement for sharing 20% of funded campus clusters through CCSTAR, and that Open Science Grid is mentioned as an important option for federating your local computing capacity so that it's made available to researchers beyond your campus. So that's mentioned in the 20% requirement. Additionally, PATH is mentioned as an important sort of partner as part of NSF's investment in national cyber infrastructure, and that proposers are recommended to contact us because we can provide various types of support for helping you guide your proposal. And that includes support letters, iterating and confirming your plan for sharing resources via OSG, and consulting for other aspects of your proposal. For example, we can help you generate science drivers and make sure that those are articulated in a way that justifies the computing resource that you're going for. We can help you propose how you might support researchers to use the Open Science Grid, whether through OSG Connect or perhaps pursuing or investigating the option of having a local access point. So please get in touch. We've got a designated email address for supporting CCSTAR proposals that goes just to our executive director, technical director, and myself. So you can feel sort of secure in writing to that address versus our general support queue.
And Lauren,
Yes.
There is an upcoming deadline of March the 1st, but this year there's also a second deadline. So if you haven't started on this yet, I would suggest you shoot for the October 11th, but start on that one right now. Surprise yourself and get it done in the next couple of months. So, but yeah, that's a good thing to remember.
And just to sort of clarify that, we don't expect that you have already gotten in touch with the Open Science Grid by this point in order to go for that March 1st deadline. So if you're still sort of ramping up your proposal efforts, there's plenty of time to get in touch with the Open Science Grid. But as we get closer to that date, you might want to give us at least a week notice. Mainly because there will be others who will be trying to coordinate with us too. But we will scramble to make sure that we can do whatever we can to support your CCSTAR proposal. So given that CCSTAR awards require that 20% sharing, I also wanted to talk just a bit about resource sharing into the Open Science Grid. And the key takeaway is that you get to control what resources are shared into the Open Science Grid. And that's really critical to the Open Science Grid's model of sharing and to its success. There are very few requirements in terms of what amount of resources you share. In fact, there are no requirements in terms of what amount of resources you share. And we make our services and tools work for just about any type of scheduler, including more cloud-like implementations of local resources. Your resources don't even have to be physical resources on your campus. They can be resources that you've procured through commercial cloud. And we work with different operating systems as well, because the fact that we can run containers means that we can still provide a fairly homogeneous environment to the end users whose jobs will run through OSG on your cluster. There are over 100 US campuses already federated, and like I mentioned, many more internationally, most of whom support in some way the open science pool. And owners always decide which pools they share with. For CCSTAR purposes, like I mentioned, most people choose exclusively the open science pool, although some that have stakes in other multi-institutional collaborations may choose to support some of those too. In terms of resource sharing, the technology component is that we operate on our end a compute entry point that runs on a server in our jurisdiction that merely submits jobs via your local existing cluster scheduler. And then the jobs that we run on your cluster wake up and report back out to the open science pool and say, I can accept OSG user jobs now. So there's kind of a job layering, but you get to specify which types of resources on your cluster, whether it be via partitions or what the job requirements or job requests are through your existing cluster scheduler. So you get to decide what resources, how many of those you can use your local scheduler to adjust priority. And then beyond the fact that your scheduler will tell you exactly how much of your cluster was used for our jobs submitted to your cluster. So those are submitted under an OSG user. We also provide accounting on the page that Mike was mentioning before, our grid accounting system, in terms of which OSG users, which research projects ran on your site and with how much computing usage each of them got. So that's resource sharing. And if you want to know more details about that, the February workshop, the 8th through the 9th, and the OSG All Hands meeting will both include opportunities to ask detailed questions about the technology that run those. In fact, there will be a presentation on OSG technologies that enable resource sharing. That's just enough detail for a campus in terms of covering security and what types of features your cluster might need to have. There aren't many in order to maximize which research projects can run on your cluster. So I already mentioned that we do HTC facilitation training. This is also part of our services for building local DHTC capacity. So don't forget that. There's ample opportunities to shadow and learn from our facilitators and engage at various community meetings to learn from others, including other campuses that are supporting high throughput computing in some way on their campus. Just wrapping up. Next steps, you and your researchers can use OSG now. Just as a reminder, go to OSG Connect and sign up. If you'd like to discuss any of the services I mentioned for your campus or for your researchers, you can otherwise get in touch with us directly via support@opensciencegrid.org. And again, I'll just reiterate that we've got a separate email address that's just OSG leadership if you'd like to discuss consulting and letter of support for a CCSTAR proposal. And the next two opportunities to learn even more detail about things I discussed today. First is that DHTC campus workshop. The next one is February 8th through 9th. And then, like I mentioned, the OSG All Hands meeting that's just about a month later is 5 days, the first few of which are most relevant to researchers and campus staff like yourself. And with that, I'd like to take any other questions in addition to what we already discussed, and feel free to reach out to me directly if you'd like.
Thank you, Lauren. Does anybody have any questions about the specifics that Lauren talked about, or about the CCSTAR proposal? I think we have quite a few people on here that have probably submitted proposals in the past and would be happy to answer your questions. And like Lauren said, you know, you can still start now and submit those for the March 1st.
Back to the contact address for the CCSTAR
Yeah, I can go back to that. It's cc-star-proposals at opensciencegrid.org.
Hold up, there was a slide.
Yeah. Oh, sorry, I didn't hit the last share button.
Okay.
There we go. Thank you, Mike.
That's all I had. So
Great.
We have a question in the chat. How does username integration between local usernames and OSG usernames work? Perhaps that's too technical, probably not.
Yeah, so I guess I would ask for clarification. Do you mean when we're talking about OSG users whose jobs have been up running on your cluster, or for your local researchers when they want to run on OSG? Or both?
Maybe you just give, can you?
Yeah, I'll give the both. So through OSG Connect, your researcher would have an OSG specific user account on our access point that is completely independent of their local campus identity. If you have a local access point, you can use your campus's local authorization system, like many campuses do on their local clusters, so that this could even be like their campus ID and password, or it can be whatever username space you typically associate with your local compute system. So with the local access point, that is entirely up to you. Now, in terms of researcher jobs that run on your cluster, our compute entry point, the OSG compute entry point that will run specific to your cluster, will submit jobs through an OSG account. And usually we ask sites to call that username OSG01, OSG02, but you could have it be something else if you wanted to, if you were worried about collisions with other usernames. And that's all that you'll see. So like if you have a Slurm cluster, you'll see Slurm jobs running on likely whole nodes, or if you want partial nodes, but under the OSG 01 or OSG 02 user. It's just one account that you create for each pool that you support. So if you support one pool, you need one OSG account. And within that, we start up a job executable that can then turn a node on your cluster into multiple slots for OSG user jobs. So there may be multiple OSG users whose work ends up running on your cluster, and you won't really see their usernames. This is partially by design for security reasons, but if there were any issues created by jobs on your cluster, you can easily turn off the OSG backfill and get in touch with us, and we can easily identify which users were contributing to those issues.
Okay, we have another question from Don Rousseau. Is it possible to set up a local access point that can be used by several campuses, some with HPC/HTC and most without?
Absolutely. It really doesn't matter what type or amount of other computing systems are available locally. And an access point that you operate can be used by whomever you deem appropriate to support on that access point. Of course, things like user authorization and identities can become a little more complicated if it's multiple campuses sharing an access point. But again, that's entirely under your purview and control.
And is that something you would help them set up if they become providers?
Yeah, I mean, the staff who contribute to OSG are almost all also involved in running computing systems on their own campuses for their own research communities. And so one way or another, we've got expertise or can point you to expertise on things like how to set up user authorization. But there isn't sort of one bespoke solution that you have to implement for OSG.
Very good. Then Patrick Schmitz said, I understand Igor and IceCube I guess it's Igor or Igor, used OSG to scale up a multi-cloud experiment. Very cool. Has anyone
Yes.
considered using OSG to front Lambda services for swarms of small jobs? Or could OSG be set up to work like Lambda with data drops triggering the processing?
So I don't know what Lambda is. And some context there might help. Is that person willing to speak for
Sure,
both
this is
Lambda?
Patrick. Hi, Lauren. So Lambda is a serverless technology that basically, the jobs that you describe as being ideal for OSG are a lot like the profile of what's ideal for Lambda, where you've got basically, instead of running a server, you have a method that's invoked periodically, and it's really, really easy for people, including researchers, to configure, because you just basically register a method, and when it needs to run, it runs instead of configuring a server. And usually it's for data flows where then you drop data somewhere and that triggers an invocation of the method to process it. So it's the serverless model for computing. And it just seems like there's a match of the kinds of jobs that you're doing to that. And since some workflows are moving to these Lambda architectures in the cloud, I was thinking, oh, it'd be kind of cool if there was an alignment so that people could use OSG that way. And then it'd be easier to hybrid between OSG and cloud stuff as that's coming along.
Yeah, so without knowing some more of the details, and thank you for your description, Patrick, this all certainly sounds like it would jive, just like you're saying, with the way that OSG and really the principles of high throughput computing operate. And ultimately, because the Condor scheduler is so critical on the user end, I think what you're describing would come down to sort of some sort of layering, which projects like IceCube have done. So, for example, they use layering such that they have jobs that run inside the OSG user jobs that then report back out and grab different types of workloads that are not specifically communicated through Condor. So there are opportunities there. And otherwise, OSG is already working with serverless sort of technologies, for example, Kubernetes, which Condor also integrates with well. So there's probably ample opportunity for what you described, Patrick, if it's not already being pursued. And it may just be that I don't know.
Cool, thanks.
Well, we're kind of running up to our time here. It's about 12:57. So thank you again, Lauren. And as she mentioned, I have put up here a slide for next month, which is our regularly third Wednesday of the month, which will be February 17th, where Susan Ivy will be leading a panel of our emerging centers experts, in quotes, who will share their experiences and lessons learned, which may be applicable to the development of coordinated approaches to supporting RCS cyber infrastructure, RCD, in your organization. So we'll have some special guests, including Jason Wells from Bentley University, Doug Genuine from previously University of South Dakota, and now is at Arizona State, and Lauren Michael from University of Wisconsin at Madison. And they'll each talk about a little bit about, address some questions that we have, specific questions, and talk about how their centers were developed, and share some of their lessons learned. And then I suspect we'll have a robust conversation around that. And we will, in the end, try to find a place or a way that we can share our documents so people aren't recreating the wheels when they are developing their own centers. So if anybody else has any questions, I'm sure Lauren, she gave you emails. You can please send questions to those emails about the Open Science Grid. And if nothing else, going once. All right, we'll send out the link to this recording, and we'll see you all next month.